Hello, and welcome to the Daily AI Brief. I'm your host, bringing you the latest innovations and developments from the world of artificial intelligence. In today's episode, we have exciting topics ranging from breakthroughs in AI model efficiency, advancements in genomic analysis, and new frameworks for evaluating large language models, to innovative strategies in data security and marketing. Stick around as we explore how these technologies are shaping our world. Let's dive right in. NVIDIA is redefining efficiency in AI with the launch of its Nemotron 3 Nano 30B model. Housing 30 billion parameters, it promises a substantial leap in reasoning capabilities and processing speed, primarily through the innovative use of Quantization Aware Distillation. Here's the backdrop. NVIDIA unveiled the Nemotron 3 Nano 30B A3B NVFP4 model, aimed at revolutionizing conversational AI and complex reasoning tasks. By marrying QAD with the architecture, the model substantially boosts throughput while minimizing memory usage, solidifying its status as a leader in efficient AI systems. Technical drill down. The model incorporates a sophisticated hybrid mixture of experts (MOE) architecture, combining the potent Mamba 2 and grouped query attention layers. This architecture is enhanced by QAD, a technique that optimizes performance post-quantization without sacrificing accuracy. By using NVIDIA's advanced Blackwell GPUs, the model capitalizes on state-of-the-art quantization strategies, translating into robust performance even after dramatic memory reductions. Numbers and benchmarks. Numerically, the Nemotron 3 Nano accomplishes impressive feats. A dramatic 72% reduction in memory usage and a 14.5x increase in inference speed post-quantization mark significant improvements. Furthermore, with a staggering 1 million token context window, the model stands ready to tackle highly complex tasks with nuanced accuracy. Trade-offs and limits. Despite these advancements, there are potential trade-offs to consider. The long-term performance of QAD-optimized models under diverse real-world conditions remains a question. Similarly, the reliance on high-end hardware such as Blackwell GPUs could limit smaller institutions from accessing these capabilities, possibly slowing the democratization of such advanced technology. Practical applications. For those eager to engage with the technology firsthand, visiting NVIDIA Labs, research.nvidia.com/labs Nemotron/Nemotrons, Nemotrons 3 source OpenA, offers more in-depth exploration of Nemotron models. Additionally, the NVIDIA Developer Toolkit, developer.nvidia.com/nemotron.utim source OpenAI, provides an opportunity for practical, hands-on experience, which could be invaluable for developers looking to implement QAD in their applications. In summary, NVIDIA's Nemotron 3 Nano 30B stands as a game-changer, effectively pushing the boundaries of AI model efficiency by demonstrating how state-of-the-art quantization techniques can continue to evolve, enhancing both reasoning capabilities and operational speed. DeepMind has taken a significant step forward in the field of genomics with the release of AlphaGenome, a groundbreaking AI model designed to deepen our understanding of the human genome through the analysis of DNA sequences. This innovative tool is geared to address some of the pressing challenges in genomic research and personalized medicine. What happened? AlphaGenome is highly adept at evaluating long DNA sequences, boasting the ability to process up to 1 million base pairs. This capacity is instrumental in analyzing the regulatory sequences that affect gene expression, and it holds potential for identifying the genetic basis of complex diseases. It uniquely incorporates RNA splice junction modeling, thereby improving predictive accuracy concerning gene regulation and the identification of genetic drivers in diseases. Hybrid architecture. AlphaGenome utilizes a hybrid combination of transformers and UNets, which is a state-of-the-art approach in processing large datasets. Transformers, known for their effectiveness in sequence prediction tasks, enable the model to maintain high accuracy over long DNA stretches. Fine resolution. The model operates at an individual nucleotide resolution, allowing it to provide precise predictions regarding genetic variance impacts. This granularity is essential for understanding how small genetic variations can influence larger biological functions. Framework for non-coding regions. Non-coding regions of DNA, which are often overlooked, are comprehensively analyzed by AlphaGenome, contributing to a broader understanding of genome functionality. Open source potential. The model is available as open source, which encourages integration into genome-wide association studies, GWAS, and other research workflows, fostering collaboration and accelerating innovation. Benchmark performance. In rigorous testing, AlphaGenome outperformed existing models in 22 out of 24 evaluations focused on single DNA sequences, highlighting its superior predictive capabilities. Variant impact prediction. The model matches or surpasses standard benchmarks in 24 out of 26 evaluations concerning variant regulatory effects, demonstrating its robust applicability in practical scientific contexts. Trade-offs and limits. Experimental validation. While promising, AlphaGenome's predictions currently require experimental confirmation before they can be reliably used in clinical settings. This step is critical for ensuring the safety and accuracy of diagnostic and therapeutic applications. Diverse population performance. The model's accuracy on genetically diverse populations remains an area needing further study. Ensuring it provides equitable insights across diverse genetic backgrounds is essential for broad clinical application. Practical applications and engagement. Implementation and exploration. Researchers and developers can access implementation details through the DeepMind blog, which offers guidance on how to work with AlphaGenome in various scenarios. API access and community engagement. The model's API allows for comprehensive genomic data analysis. Researchers can engage with community-contributed workflows on platforms like GitHub, facilitating shared advancements and troubleshooting. AlphaGenome represents a transformational advancement in genomics, offering significant possibilities for healthcare, diagnostics, and the understanding of disease mechanisms. By improving our ability to interpret complex genetic data, it propels the field towards new frontiers in personalized medicine and innovative drug development. The model could also fundamentally alter research methodologies, thereby influencing future clinical practices and genetic counseling. However, sustained research and validation efforts are necessary to fully realize its clinical potential, particularly in diverse populations. The world of artificial intelligence, AI, particularly in the development and evaluation of large language models, LLMs, is witnessing significant transformation with the introduction of the TruthTensor framework. This groundbreaking approach redefines how LLMs are assessed by leveraging live prediction markets, moving away from the static benchmarks traditionally used in this space. What happened? In simple terms, TruthTensor shifts the focus from static assessments to dynamic evaluations, providing a richer understanding of how these models function in real-world, unpredictable contexts. By being anchored in over 500 live prediction markets, the framework aims to more accurately reflect the intricacies of human-like decision-making, which traditional methods often fail to capture. Technical drill down. Live prediction markets. The core strength of TruthTensor lies in its use of live prediction markets. This involves real-time data and dynamic scenarios where predictions fluctuate based on current events. These markets allow for the evaluation of an LLM's ability to interpret and predict outcomes in ever-changing landscapes, a crucial factor in assessing decision-making capabilities. Probabilistic scoring. At the heart of TruthTensor is probabilistic scoring, which evaluates models not only on outcome accuracy but also on how well their predictions align with the likelihood of future events. Critical metrics like calibration, where the probability predictions match actual outcomes, and narrative stability, which assesses consistency in interpretations over time, offer multidimensional insights. Robustness checks. The framework includes robustness diagnostics to ensure that the evaluations reflect reality, even as conditions change. This means that models are not just tested for correctness, but are also challenged on their adaptability to shifts in data distribution, a common occurrence in the real world. Numbers benchmarks. TruthTensor actively evaluates LLMs across more than 500 live prediction markets, providing diverse data points to generate comprehensive performance profiles. This approach marks a departure from narrow, singular metric evaluations and sets a precedent for a more detailed understanding of AI capabilities. Trade-offs limits. While TruthTensor offers numerous advantages, there are inherent trade-offs. The long-term applicability of such a dynamic evaluation system remains uncertain across the varied scenarios that LLMs may encounter. Additionally, as with any system relying on external data, biases inherent within these live markets could skew results and affect assessment accuracy. Practical applications. For those looking to explore TruthTensor's potential, practical insights can be gained by visiting TruthTensor.com, htruthTensor.com, where the framework is available for use. Additionally, related studies and analyses can be reviewed within the ACL anthology, providing deeper academic and practical understanding of the framework's utility. By integrating real-world scenarios into LLM evaluation, TruthTensor sets a pioneering standard, pushing the boundaries of how AI effectiveness is measured. This framework not only offers a more nuanced view of model capabilities, but also encourages further innovation in developing LLMs that can thrive amidst complexity and uncertainty. A recent study explores the pioneering integration of gossip protocols into decentralized federated learning systems, dissecting the implications for data privacy and learning efficiency. This transition from a centralized aggregation model to a peer-to-peer network seeks to enhance the privacy-preserving nature of federated learning, a methodology that remains central to confidential data handling in the AI domain. What happened? The research focuses on implementing gossip-based, decentralized federated learning models that elevate both data privacy and operational efficiency. A key innovation is the deployment of differential privacy techniques to safeguard individual data without hindering the learning progress. This approach contrasts sharply with conventional centralized models, promising enhancements in privacy protection and system decentralization. Technical drill down. Two distinct models were devised, the traditional centralized FedAvg model and a novel decentralized model utilizing gossip protocols. The latter facilitates the sharing of model updates directly between peers in a network, effectively bypassing central servers. Client-side differential privacy, a cornerstone of this system, imbues local model updates with noise, thereby preserving user data integrity. The differential privacy mechanism specifically integrates noise calibrated against certain parameters to ensure minimal disruption to model accuracy. Numbers and benchmarks. The study extensively used the non-IID MNIST dataset to scrutinize these models, although exact performance metrics were not detailed. The focus, however, was tightly on assessing convergence speed and stability, key indicators of model efficiency and reliability in decentralized setups. This suggests the framework's robustness, but also highlights the necessity for more granular data from varied datasets to affirm broader applicability. Trade-offs and limits. The application of differential privacy inevitably introduces a trade-off between privacy and efficiency. Stronger privacy constraints can lead to diminished learning efficiency, necessitating a careful balance suited to the use case. Furthermore, the study primarily navigates through a single dataset, leaving the generalizability to diverse data environments an open question. Practical applications. Practitioners interested in exploring decentralized federated learning can access resources and experimental setups from the corresponding GitHub repository. github.com/p2pfl. By adjusting privacy parameters such as epsilon values, one can observe the nuanced impacts on model convergence and privacy, critical for tailoring solutions to particular privacy needs. Potential implications. This groundbreaking decentralized approach presages a potential shift in federated learning paradigms, optimizing for enhanced security without sacrificing learning effectiveness. Its implications stretch from healthcare to finance, where data privacy is paramount. Researchers and developers can leverage these findings to design AI systems that not only align with privacy regulations, but also enhance trust and transparency in data handling processes. By seamlessly integrating gossip protocols and differential privacy, the study not only offers a roadmap for decentralized learning architectures, but also fuels ongoing debates on the equilibrium between data privacy and system efficiency. Though further exploration is required, particularly with different datasets and in real-world scenarios, this research lays a significant foundation for future explorations in decentralized federated learning enhancements. AI agents increasingly rely on external data acquisition strategies, predominantly focusing on web scraping and APIs. Each method offers distinct advantages and challenges that significantly influence the functionality of AI systems and their compliance with legal and ethical standards. Web scraping. Web scraping refers to the automated extraction of raw data from web pages. This process involves custom built scrapers navigating web structures to fetch data. Traditional web scraping can be resource intensive, demanding tailored development to handle the diverse architectures across websites. For enterprises, this means deploying technical expertise to maintain scrapers, especially as websites frequently update layouts. # AI-driven web scraping tools. Emerging tools like Autoscraper and platforms such as Energent.ai are changing the landscape. Autoscraper utilizes large language models to autonomously generate web scrapers that adapt to website changes, reducing the need for constant human intervention. Energent.ai offers a no-code solution, lowering the entry barrier for businesses without technical teams. Apify further enhances scraping capabilities by overcoming obstacles like CAPTCHA and session management, ensuring data is both clean and competent. APIs, a structured interface. In contrast, APIs provide a structured way to access data through predefined protocols. This method simplifies the extraction process by delivering data in a consistent format. APIs are often preferred for their reliability and compliance with data providers' terms of service. However, they limit data access to what providers choose to expose, which might not cover all user needs. # numbers and benchmarks. Companies utilizing these automated scraping methods can significantly curtail manual workload, resulting in substantial time savings. The effectiveness of AI-driven tools is contingent on the complexity of website layouts, directly impacting data accuracy and reliability. A striking benchmark is the reduction in time spent on manual data collection, which AI tools have halved in many cases. Trade-offs and limits. Web scraping introduces complex legal questions about data ownership and copyright infringement. The ethical implications are paramount, necessitating tools that ensure compliance with privacy laws. Moreover, AI tools require regular updates to stay effective against dynamic and intricate websites, demanding investment in ongoing development. Practical applications and what to try. For businesses looking to harness these strategies, exploring Apify's sophisticated tools is advisable, particularly for scraping complex websites. Energent.ai's platform can provide automated scraping without coding expertise, streamlining data collection processes. Researchers and developers can delve into Autoscraper via our Xeeve to understand autonomous generation of scraping solutions. Balancing ethical considerations with technical capabilities, web scraping and APIs represent crucial strides in the ever-evolving domain of AI data acquisition. These methods are instrumental in shaping efficient, responsive AI systems while navigating the nuanced challenges of legality and ethics in data handling. The landscape continues to evolve, paving the way for sophisticated, compliant data acquisition strategies in the AI sector. Sentra, co-founded by Ron Ryder, is transforming cloud-native data security by focusing on dynamic data governance. This approach acknowledges the volatile nature of modern data infrastructures, ensuring enterprises have the tools to maintain visibility and control, critical for mitigating security risks. Technical drill down. Sentra's strategy hinges on the integration of AI-powered tools such as Sentra Jagger, which automate compliance processes and manage data security dynamically. Utilizing advanced algorithms, the platform enables deep data classification and continuous monitoring, ensuring real-time oversight and actionable security insights. Sentra Jagger, the AI assistant, creates a new layer of interconnectedness, providing real-time security recommendations. This AI-driven approach contrasts with traditional security methods by adapting to real-time changes in data environments, which is crucial as data sprawl continues to expand. Numbers and benchmarks. Sentra's financial backing is substantial, with a recent Series B funding round garnering $50 million, pushing total investments beyond $100 million. This financial growth pairs with impressive operational metrics, such as their 300% year-over-year revenue increase, positioning Sentra strongly in the competitive market. Practical steps to implementing Sentra solutions. For organizations keen on leveraging Sentra's capabilities, starting with platform integration is recommended. For instance, utilizing integration features with widely used platforms like Microsoft 365 can enhance data governance, facilitating a more holistic management strategy. Another practical application involves exploring Sentra's data security for AI agent solution, which integrates seamlessly with tools like Microsoft Copilot Studio, Amazon Bedrock, and OpenAI ChatGPT Enterprise. These integrations allow enterprises to proactively secure data in AI-enhanced environments, a necessity as the adoption of AI technologies accelerates. Trade-offs and limits. While Sentra shows significant promise, there are inherent trade-offs and limitations. Interoperability challenges could emerge given the diverse IT environments enterprises operate within. This means IT teams need to be vigilant in managing system compatibility. Moreover, Sentra's heavy reliance on AI technology, while innovative, requires precise configuration and diligent oversight to prevent security lapses and ensure data protection. Incorrect configurations could lead to vulnerabilities, so a balance between automation and human oversight is critical. Implications of dynamic governance. Sentra's advancements illustrate a promising shift towards a future where cloud data governance is more proactive and responsive. As organizations widely adopt AI technologies, Sentra's tools support better risk management and compliance, potentially setting new industry standards. By automating significant portions of the data governance lifecycle, including compliance with regulations like GDPR and CCPA, enterprises can devote more resources to innovation rather than maintaining regulatory alignment. In summary, Sentra is not just another player in the cloud data security domain. It is acting as a catalyst for change, promoting a dynamic and AI-integrated approach to data governance that adapts to the ever-shifting landscape of modern enterprises. CambrianEdge.ai is challenging norms in the marketing domain with its AI-native platform, unifying AI capabilities with human insight for seamless marketing collaboration. By leveraging AI for speed and complementing it with human creativity, CambrianEdge.ai aims to redefine marketing workflows across various sectors. What happened? At the core of CambrianEdge.ai's launch is its goal to dismantle traditional marketing silos, where strategy, creativity, and analytics often operate in isolation, by offering an integrated and collaborative workspace. This ambition aligns with CEO Harjeev Singh's vision to ensure AI assists rather than replaces the human elements of decision-making. The platform seamlessly integrates major large language models, LLMs, alongside custom AI solutions, enabling sophisticated data analysis and insights generation. This ensures that teams, regardless of size, can efficiently utilize AI-driven analytics tailored to specific campaign needs. Another cornerstone is its hybrid intelligence model. This model is vital because it marries AI's rapid processing capabilities with the nuanced understanding that human marketers bring, fostering a balanced approach in crafting marketing strategies. Compliance is another critical aspect, with the platform meeting stringent security standards like SOC 2, HIPAA, GDPR, and ISO 27001. This adherence provides enterprises with the confidence to securely manage sensitive marketing data. Numbers benchmarks. The platform was officially launched in October 2023. This timing is strategic, reflecting the growing demand for AI integration within marketing domains. According to McKinsey, while 72% of organizations employ AI in some capacity, less than 6% achieve noticeable ROI. CambrianEdge.ai is poised to significantly elevate this figure as user adoption increases through its innovative approaches. Trade-offs limits. Despite promising features, the platform's real-world efficacy across diverse marketing contexts remains to be fully validated. This uncertainty extends to its potential ability to adapt and mesh within existing legacy systems that firms might still rely on. Another point of contention is the potential disruption to established marketing agency models. As AI-powered strategies gain prominence, traditional agencies might need to evolve rapidly or risk obsolescence. Practical applications. Corporations looking to integrate AI should explore CambrianEdge.ai's customer case studies and resources to understand real-world applications and benefits. The platform offers extensive AI literacy and operational training, critical for marketing professionals aiming to adapt to an increasingly AI-driven environment. Engaging with these resources can significantly improve team competence and adaptability. CambrianEdge.ai exemplifies how technology and creativity can coexist, pushing marketing into a new paradigm. As AI transforms marketing, the emphasis remains on ensuring that technology enhances rather than diminishes human creativity and strategic input. This balancing act is essential for both the platform's success and the broader acceptance of AI-driven solutions in marketing workflows. Exploring new horizons in AI, recent research introduces memory-based enhancements for AI agents through frameworks like PISA and ReasoningBank. This development represents a crucial step forward in enhancing an agent's adaptability, interaction efficiency, and task performance by leveraging more structured and efficient memory management systems. Frameworks Overview 1. PISA Framework. Introduced on October 12, 2025, PISA is a memory-driven AI framework that focuses on enhancing the adaptability and long-term memory retention of AI agents. It employs a trimodal adaptation mechanism. This mechanism facilitates the creation, updating, and evolution of memory schemas, thereby ensuring that memory is continuously enhanced and remains relevant to the tasks at hand. The use of a hybrid architecture, integrating symbolic reasoning with neural retrieval, allows for improved accuracy and efficiency. Symbolic reasoning aids in structuring information logically, while neural retrieval ensures that relevant data can be accessed swiftly and accurately. In evaluations, PISA demonstrated state-of-the-art performance on benchmarks like Locomo and AgQA, although specific metrics quantifying the improvement were not disclosed. 2. ReasoningBank Framework. Developed through a collaboration between the University of Illinois Urbana-Champaign and Google Cloud, ReasoningBank is designed to help large language model (LLM) agents organize past experiences into a coherent memory bank. This structured memory framework supports better retrieval and use of past information, enhancing overall task performance, notably in complex scenarios where traditional memory systems have often failed. While precise benchmarks for efficiency improvements remain unspecified, the framework has been noted to significantly enhance the way AI agents derive reasoning strategies from prior tasks. Technical insights. PISA's architecture, combining symbolic reasoning and neural retrieval, provides a dual advantage of logical processing and quick access, suitable for various applications, from basic query responses to more complex decision-making tasks. Memory management. The frameworks focus not only on storing and recalling information, but also on evolving memory representations, which is vital for maintaining context over extended periods. Challenges and considerations. Generalization. Both PISA and ReasoningBank are yet to be thoroughly validated across diverse real-world tasks, which could affect their general applicability in different domains. Scalability. There's an ongoing challenge in scaling these advanced memory systems within existing AI infrastructures, especially in environments with limited computational resources. Dynamic environment adaptability. The robustness of these systems in rapidly changing environments remains an area for potential improvement. Practical applications. For those interested in utilizing these frameworks, reviewing empirical results from benchmarks like Locomo and AgQA can provide deeper insights into PISA's capabilities. Additionally, exploring ReasoningBank's documentation might reveal strategies for effectively integrating it within LLM environments. Implications. Memory-driven AI agents promise more personalized interactions and improved context retention. Potentially, this could lead to innovations in customer service automation, where personalized insights gleaned from past interactions can enhance user satisfaction. Overall, these memory-driven strategies mark a promising shift towards more cognitively inspired AI models, paving the way for future developments that can transform the field of artificial intelligence. The telecom industry is undergoing a remarkable transformation through the integration of artificial intelligence (AI) technologies that aim to bolster both efficiency and the structural integrity of networks. This shift represents a significant advancement in how telecom networks operate. Advancements in AI integration. The conjunction of generative AI models, such as generative adversarial networks, GANs, and variational autoencoders, VAEs, with digital twin technologies provides telecom operators with enhanced simulation capabilities. Digital twins serve as virtual replicas of physical telecom infrastructure, allowing for meticulous planning and operational testing in risk-free environments. Generative AI models help simulate various network scenarios, enabling a deeper understanding of potential outcomes and timelier decision-making. AI-driven predictive maintenance. Predictive maintenance powered by AI emerges as a cornerstone of modern network management, promising a reduction in network downtime by approximately 30%. By leveraging AI to analyze vast streams of operational data, telecom providers can anticipate and mitigate failures before they occur, thus ensuring uninterrupted service delivery. Real-time data analytics. Another crucial domain where AI proves invaluable is real-time data analytics for traffic monitoring and resource allocation. AI systems can continuously analyze data flows, detect anomalies, and optimize network performance on the fly, making certain that bandwidth is distributed efficiently even during peak usage. This ability to process and act on real-time data obviates the need for manual adjustments, which are often slower and prone to human error. Potential achievements. According to industry forecasts, the implementation of AI-driven automation could decrease operational expenditures by as much as 40% by 2025. More than half of surveyed telecom engineers believe that AI could boost network operational efficiency by 40%, enabling companies to deliver more reliable services while managing costs effectively. Scalability and security challenges. However, the integration of AI within telecom networks is not without its challenges. Scalability of AI solutions can vary widely depending on the complexity of the existing infrastructure. Moreover, data security and privacy remain of paramount concern, as AI introduces new layers of complexity which could potentially expose networks to novel vulnerabilities. Practical implementation steps. To successfully integrate AI technologies, telecom companies should explore APIs that facilitate the inclusion of generative AI into their existing network management systems. Implementing AI-driven predictive maintenance strategies could be the first step to significantly reducing downtime. Additionally, investing in tools that offer real-time network performance analytics would enhance decision-making capabilities. In summary, AI stands poised to fortify telecom networks by drastically improving service reliability and operational excellence. As these technologies continue to evolve, they will undoubtedly reshape the landscape of telecom services, making the industry more adaptable and resilient. That's it for today's episode of the Daily AI Brief. We've explored how AI is not only enhancing efficiency across various domains, but also challenging existing paradigms in industries from marketing to telecom. As these technologies continue to develop, the intersection of AI with other fields promises even more exciting opportunities and challenges. Join us next time for more insights into the world of AI. Thanks for tuning in, and stay curious.